So welcome to this video, guys. We are going to be talking about Bernoulli's equation. So the first thing you have to know about Bernoulli's equation is how to recognize it whenever you see it. So Bernoulli's equation always takes this form: dy dx plus p, which is a function of x, y, and is equal to q, which is also a function of x, y raised to power n. This is the form a Bernoulli equation always takes. Dy dx plus there will be a y and there will be a y raised to power something. That raised to power something is our n. So anytime you see this type of equation, anytime you see this format of equation, this is a Bernoulli equation. So whenever you see this, the solution Bernoulli gave us to solving this type of equations is this substitution. He uses this substitution. Let z equals to y raised to power 1 minus n. So this is the substitution we are going to use to solve any Bernoulli equation we encounter. So let z equals to y raised to power 1 minus n. So this means the z dx equals to, we differentiate this with respect to x. That means we are differentiating implicitly. That means this one will come down 1 minus n, y 1 minus n minus 1, right? Implicit differentiation dy dx. So it means the z dx equals to 1 minus n, y 1 will cancel 1 minus n dy dx. The reason why we are using this substitution, let z equals to y raised to power 1 minus 1, y 1 minus n, is to reduce this Bernoulli equation into another equation that we can solve using an integrating factor. Please, I've done a video on integrating factor. If you have not checked it out, go and check it out. We are going to be using it in solving these equations. And if you are not good with integrating factors, you might not be able to catch up with us. So make sure you check out the video on integrating factors before we proceed. So after we have done this, we have our z as z is equal to what? Y raised to power 1 minus n. And we have our z prime, our z dx as 1 minus n, y minus n, y prime. Don't forget these two equations. These two are what we will be using to simplify this equation. Whenever we get there, I'll let us know. So now let's solve question number 1 and question number 2 using this understanding that we have. Let's solve the first one. So first thing first, you have to confirm that your equation, that your ODE is in the form of a Bernoulli. Y prime plus x minus 1. I can write over x as x minus 1 y equals to x y raised to power 2. So this is our y prime, this is our p y, and this is our q y raised to power n, which means our n equals to 2. Our n equals to 2. This is in the form of a Bernoulli. N equals to 2. So what are we going to do? Our substitution, z equals to y raised to power 1 minus n equals to y raised to power 1 minus our n is 2, which means y equals to z equals to y raised to power minus 1. So this substitution is what we are using. What will use z prime be? Z prime equals to, let's differentiate this. Minus 1 will come down, y minus 2, y prime, right? So these two equations, don't forget them. Z equals to y raised to power 1, y minus 1, and z prime equals to this, minus 1, y raised to power minus 2, y prime. So what are we going to do next? We are going to look at this our equation. Then divide through by y raised to power n, divide through by this. So we have something like y minus 2. You know, when you are dividing by y squared, the same thing as multiplying through by y minus 2. Y minus 2, or let me write it in form so you will not get lost, please. Let me write it in the normal form. We have y prime divided by y squared plus x minus 1y divided by y squared equals to x y squared divided by y squared. We are dividing through by y squared. So this one can come up and become y minus 2 y prime plus 1 will cancel 1 here, x minus 1 y minus 1, right? Am I correct here? These will cancel out each other and becomes equals to x. So what next are we going to do? After we get to this thing, you are going to compare this to your z and your z prime. You can see z equals to y minus 1. Z is already here. But look at this z prime. Y minus 2 y prime is already here. But it makes this minus 1 to make sure the equation is complete. It makes this minus 1, don't forget this. So that means this minus 1, we are going to multiply this equation through by 8. We are multiplying the equation, this equation that we have here, we are multiplying it through by minus 1. So if I multiply this by minus 1, I have minus y minus 2 y prime minus x minus 1 y minus 1 equals to minus x. I multiply through by minus 1. Minus 1 is the same thing as multiplying through by minus. So I have this type of equation now. From here, I have this. This is same thing as z prime. I have y minus 1, which is same thing as z. So I can transform this into z. I transform it from an equation in y and y prime into an equation in z. So now let's transform this. This is same thing as z prime minus x minus 1, y minus 1 is same thing as z equals to minus x. Now this has been simplified into an equation we can solve using integrating factors. Let me clean this. Please don't forget to jot while you're watching, so you will not get lost. Please don't forget to jot. So we have z prime minus x minus 1z equals to minus x. So what's our integrating factor here? Our integrating factor equals to what? E raised to power integral of p dx. Our p here is minus x minus 1. So we have e raised to power integral of minus x minus 1 dx, which is the same thing as saying e raised to power minus integral of 1 over x dx, right? Same thing as e raised to power minus ln x. We don't need any plus c. So what we have here is what? Our integrating factor equals to e raised to power ln x minus 1, right? E raised to power ln will cancel out and our integrating factor turns to x minus 1. So what do? We multiply our equation through by our integrating factor. We multiply this equation, we multiply through by our integrating factor. So we are going to have something like x minus 1 z prime. I'm multiplying everything through minus x minus 1, then we are multiplying through minus 1, another x minus 1, z equals to minus x dot x minus 1. I multiply the equation through by the integrating factor. So now I have x minus 1 z prime minus x minus 2z equals to minus, this is already 1. 1 minus 1 is 0. X raised to power 0 is 1. Minus 1. So looking at this, after we have used integrating factor, don't forget this. After we have used integrating factor, you are going to look at your left hand side. We are going to look at this left hand side. This left hand side, we have differentiated z to get z prime. We differentiated x raised to power minus 1 to get minus x raised to power minus 2, which means I can rewrite this part as differential of x minus 1 z equals to minus 1. So what do I do next? I integrate both sides with respect to x, which means x minus 1z equals to minus x plus c. I've integrated this side. If you integrate minus 1 with respect to x, you get minus x plus c, or I can write it as c minus x. I just moved it. So now I make my z disobeyable formula by multiplying through by x, or I should say z over x. Don't forget, x minus 1 is the same thing as over x equals what? C minus x. So bring your c to the other side by multiplying through. We have z equals what? Cx minus x squared. But we are not done yet. Why? Don't forget that z equals to what? Initially, z equals to y raised by 1 minus n, and the n we were working with is 2. Z equals to y1 minus 2, which equals to y1 minus 2 is minus 1. So what do? We have to make sure our answer is in form of z, not in form of z. Should be in y, not in z. Our final answer should be in y. Don't forget, the aim of every OTE is to find the y, the dependent variable, to find the value of the y. So this means this z equals to y raised to power minus 1 is the inverse, or let me say equals to 1 over y. So I just transpose both of them and say y equals what? I take it up. So this one I'm going to invert it to 1 over cx minus x squared, which is the same thing as saying cx minus x squared raised to power minus 1. And that's the solution to our first ODE using Bernoulli's substitution of z equals to 1 minus n. So this is the first solution to the first question, the first Bernoulli equation, and that's the answer to it. So we are going to the second one. We are going to the second question. So don't forget, the first thing is always to make sure your equation is a Bernoulli equation. Always make sure your equation is a Bernoulli equation. Now let's check if the second one is a Bernoulli. How do you do that? Y raised to power 4 is present, so yes, is a Bernoulli equation. Y is present here, y prime is present here, y raised to power 4 is here. But you have to restructure it to make it look exactly the way Bernoulli says it should look. How? Let's write this equation. Minus x cubed y prime plus x squared y. I just changed the position of both of them. Equals to y raised to power 4 cos x. Let y prime, let it stand alone. So we have to divide everything through by minus x cubed minus x cubed minus x cubed. This one will cancel out, right? So we have y prime minus x squared will cancel this one out. So we are left with y over x equals to what? Minus x cubed. I can bring it up and say x minus 3, right? Yes. Y raised to power 4 cos x. So this is now looking like a Bernoulli equation. And y raised to power 4, this is y raised to power n, which means our n equals to 4. So we say z, let z equals to y raised to power 1 minus n, which means y 1 minus 4, which is y minus 3. So this is our z. Let's write it somewhere. Z equals to y raised to power minus 3, which means z prime, our z dx equals to what? Minus 3y minus 4 y prime. You differentiate z with respect to x. So z prime equals to minus 3y raised to power minus 4 y prime. So what next do we do? The next thing we are going to do is to what? To divide through. This is the equation we are going to be using now. We are not using this equation anymore. We are using the simplified Bernoulli equation. So we divide through by y raised to power 4. The one that has the highest, the one that has the n, the one that has y raised to power n, we divide the whole equation through by y raised to power n, and our n is 4. So we divide it through by y raised to power 4 over y raised to power 4 over y raised to power 4, so that it will cancel out on this side. So it is cancelled out on this side. I can now bring this to the other side and say y minus 4 y prime minus, there's already one y here before. This 1 over x, please. 1 over x. So this one will become 3, and that turns it to y minus 3. I'm bringing it up. 1 over x y minus 3 equals to, I cancel out minus 4 on both sides, minus x cubed, x minus 3 cos x. Now, what do you do next? You compare it. Is z supposed to be where it is? Is z prime supposed to be where it is? Looking at this, we have our z equals to y minus 3. It's already where it's supposed to be, yes. But look at z prime. Z prime, there's minus 3 in front of z prime. But there's no minus 3 in front of this one. So what do? You multiply this everything through. By what? By minus 3. The one that is in front of z prime. Multiply the whole equation through by minus 3. So we have minus 3y minus 4y prime. And multiplying this equation through by minus 3. Minus times minus gives us plus 3 over x y minus 3 equals to, right? Minus is turning this to plus 2. Plus 3x minus 3 cos x. So this is now looking like exactly our z prime. And this one is looking at our z. So now let's transform it. We have this as z prime plus 3. I can write this as x minus 1, right? Yes. This y minus 3 is same thing as z, equals to 3x minus 3 cos x. Yes. So what do we do next? What we do next is that we have transformed this into a very basic first order ODE, which we can use, which you can solve using an integrating factor. And what's the integrating factor we'll be using for this? Our p, this is our p. So our integrating factor if equals to e raised to power integral of p dx, which equals to e raised to power integral of 3x minus 1, 3x raised to power minus 1 dx. I can rewrite this as e raised to power integral of 3 over, or 3 should come out, 3 1 over x dx. So if I integrate this, I have e raised to power 3 ln x. There's nothing like plus c, we don't need it. This 3 will go to the other side and we have e raised to power ln x cube. E and ln can cancel out. So our integrating factor if equals to x cube. So that's our integrating factor, x cube. So since we are gotten our integrating factor as x cube, we multiply the whole equation through by x cube. I can print this please. I need this place. So we are multiplying this whole equation through by x cube. So let's see how it turns out. X cube z prime plus 3x cube, there's already an x minus 1 here before z, equals to 3x cube, there's already an x minus 3 here before, because x. Looking at this, we have x cube z prime plus 3, this minus 1, 3 minus 1 is 2, 3x squared z equals to 3 minus 3 is 0, x raised to power 0 is 1, 3 cos x. So we have reduced this to this kind of equation. Now look at this, compare this, look at this left hand side, look at it, study it. You see that if we differentiate if we differentiate x cube, we get 3x squared, which is here. If we differentiate z, we get z prime, which is here. So it means this is the same thing as writing d into brackets x cube z is equal to 3 cos x is equal to 3 cos x. So I will need this space, please. I hope you are jotting. So this now we integrate both sides to get our z. We integrate this side to get our z. So we get integral of this is x cubed z equals to integrate 3 cos x to get what? 3 sine x. We integrate 3 cos x to get 3 sine x plus c. Sorry. We have to use our constant of integration here, please. So let's make z the solvent formula, which means we are dividing through by x cubed over x cubed. So it means z equals to what? 3x minus 3 sine x plus cx minus 3. But don't forget, we can't leave our answer in z. We have to leave our answer in y. So it means our z is what? Y raised to power minus 3 equals to 3x minus 1 sine x plus cx minus 3. Now let's make y stand alone. So we take minus 3 to the other side. And when minus 3 goes to the other side, it becomes y equals to minus 3. So it means when minus 3 goes to the other side, it becomes, we bracket everything, 3x minus 3 sine x plus cx minus 3 raised to power, when this comes here, it becomes minus 1 over 3. And that's the solution, that's the final solution to the second Bernoulli equation. And that brings us to the end of the video. If you have any question, drop in the comment section. Make sure you like this video, make sure you share to your loved ones, and make sure you subscribe. Comment any parts you see that seems confusing. Thank you. Make sure you like, make sure you share, make sure you subscribe. And that brings us to the end of the video.
You better share. Share the video.
And that brings us to the